Hello and welcome to the channel. We are continuing our coverage of this brand new Meta's Llama 3.1. In this video, we are going to fine tune this Meta Llama 3.1 model on our own custom dataset. And to top it off, we are going to do it in Google Colab on free T4 GPU. You can run the same commands on any of Jupyter Notebook or locally Windows Linux wherever you like. So let's get started. First up, if you don't know what Llama 3.1 is, I already have covered it in detail around its architecture, benchmark plus local installation in full version on my channel just today, so please search it out. Llama 3.1 is a collection of multilingual LLMs which are pre-trained and instruction tuned generative model in 8 billion, 70 billion and 405 billion size. This model has already beaten a lot of benchmarks and it is considered to be one of the best open source model out there at the moment. It's an autoregressive language model that uses an optimized transformer architecture. The tuned version uses SFT and RLHF. But for the purpose of this, we are going to work with the quantized version of it, which will be quantized via Unsloth, plus we will be using Unsloth to fine tune it. I already have covered Unsloth in great detail. It is one of the easiest way to fine tune the models on commodity hardware, and it also ensures that there is very less loss in accuracy. There are no approximation methods as all kernels are written in OpenAI's Triton language. It also doesn't really require you to do it on one GPU and then worry about portability on other GPUs. It is compatible with NVIDIA GPUs and then AMD GPUs. It works on Linux, Windows. It supports 4-bit and 16-bit context LoRA and LoRA fine tuning. And the best thing is that it is 5 times faster than other methods. Now, enough talk. Let me take you to my Google Colab, and you can simply go to colab.google.com and then sign up. Then go to runtime. It is all free. Click on change runtime type, select T4 GPU, and that's it. Let's first install Unsloth. So you can see that I'm installing Unsloth, parameter efficient fine tuning, package accelerate, and bits and bytes. So let's wait for it to get installed. And by the way, I will also give you the link to this Google Colab so that you can use it. Let's wait for all of these prerequisites to get installed. Shouldn't take too long. All the prerequisites are done here, and now let's grab our tokenizer and also the model, which is the Unsloth one, and it is a quantized version, and I believe it is in 4-bit. And I'm just going with the base model. First we will download it and then we will apply it on our custom dataset. So let me run it. And you can see that we are also giving it max sequence length to just 2048, plus data type is around none. We are not setting it, and then we are loading it in 4-bit. So the after the quantization, around 16 gig model has become just under 6 gig. How good is that? So let's wait for it to get downloaded and then we will proceed further. And the model plus tokenizer both are loaded now. Next up, let's get our LoRa adapter. So LoRa adapter is just to make sure that we only update 1 to 10% of the model weight instead of all. This makes it so faster and easier to do the fine tuning. So let me run it. So here we are just specifying the target layers or modules we want to um, update, and then we don't want any dropouts while training. And then for fast tuning, we are using this gradient checkpointing. Okay, so that is all done. Let's move forward. And if you want to learn more about these parameters, I have done various videos where I go into way more detail. Next up, let's grab our dataset. Now, this is where you can replace this with your own dataset, but make sure that is in this format like instruction, input, and response. Once you have that dataset, we are just formatting the input in this template, and then we are loading the dataset, plus we are just mapping it. So let me run it. It is going to download the whole dataset. Shouldn't take too long. It's not that big. There you go. Fairly quick. So the dataset is done. Next up, let's specify our training configuration. And as you can see that all I'm doing it, I'm just using Hugging Face TRL, and then I'm using that supervised fine tuning trainer, then specifying the base model, the tokenizer, the dataset which we are using, and rest of them are just hyperparameters like how many steps do we want, how many epochs do we want, and if we want any warm-up steps or not, what would be the gradient accumulation, and then this is the usual optimizer AdamW we are using. And as I mentioned earlier, I have done a lot of videos where I go into way more detail as what these things mean. So please check out my channel. So let me run it. And that is almost done. It is just initializing the trainer, and then we are going to run it once it is done. It takes a bit of a time, not much. As you can see, it is already 100% done. That is all good. And now it is time to start our training on that trainer which we have just initialized. So let me run it. Let's wait for it to finish. This is going to take a bit of a time because it is running on T4 GPU. And these are the number of trainable parameters. These are the number of steps. And shortly it is also going to show you ETA, the approximate time it is going to take. So you can see that the training has started, and we have around the ETA is, I would say, around 7 minutes or so. So let's wait for it to finish, and you can see that as the training is proceeding, the training loss is coming down. So let's wait for it to finish, and this is where if you have a more powerful GPU, the less time it will take to get trained. Training is almost done. As you can see that it has taken around 8 minutes and all the steps are done, almost there. So if I scroll down, you will see that the training loss has come considerably low, and this was such a small data set, such a small model. So you can imagine for a huge data set and a larger models, like if you take the base model for 3.1, it is going to take fair bit of time and fair bit computing resources. Okay, so our training is done. Now let's do the inference with our new model, which is a fine-tuned one, and for that you can use this fast inference module from Unsloth. And all we are doing it, we are just initializing the model, we are giving it a prompt, and then we are generating the output, and then we are using the tokenizer to decode it. And the question which we are answering is simply the Fibonacci sequence. So, and you can of course replace it as you like. Let's wait for it to come back, and there you go. So it has produced a very fine response here, and you can do as much inference as you like with the help of this model. Now if you want to save the model locally, or if you want to upload the model to Hugging Face, you can do so by using these commands. So you see, I'm just simply using save.retain. It is going to use in Colab, and also the LoRA model. If you don't want to, so this is a tokenizer, this is a model. Now this is for the local saving. If you want to upload it to your Hugging Face, for that you would need two things. One thing, you would need of course your repo there, and then you would need a write token from Hugging Face. So you can go to huggingface.co, sign up with your email for free account and get a free token, and then you can use this command, your name, whatever your model's name is, and your token, the write token again, and then you can upload it to Hugging Face, and that is all there is to it. So amazing stuff by Unsloth. Really hats off to Daniel, who I also have interviewed on the channel. If you're interested, please search the channel. And of course, Llama 3.1, really, it is meeting the expectations. So that's it, guys. I hope that you enjoyed it. Let me know what do you think. If you like the content, please consider subscribing to the channel. If you're already subscribed, do me a favor and share it among your network, as it helps a lot. Thanks for watching.